Hello everyone, this is Navneeta. Now we are going to discuss the topic from motion and time. So motion is a common experience in our life. So we observe birds flying in air, buses, autos, cars, bullock carts moving on roads, trains on railway tracks, and many other objects around us in motion. Right? So apart from observing motion of objects around us, we ourselves experience motion while we are walking, running, playing, riding a bicycle, etc. Similarly, we observe many objects like trees, buildings, display boards, electric poles, etc. at rest while we walk to school, right? So when we sit inside a moving bus or train, we observe that the objects like trees, buildings, electric poles, etc. appear to be moving. So all these trees, buildings, electric poles, etc. really in motion or at rest? So to understand this, we should understand the meaning of motion and rest. So the terms motion and rest. So observe here carefully. So what differences do you notice in the position of the car? Yes. So what difference do you notice in the position of the tree? So why has this difference occurred? So is it because the tree moved to the right of the car or the car moved to the left of the tree? Yes. Here we know that the position of the car has changed with respect to the tree in 2 seconds. But there is no change in the position of the tree with respect to its surroundings. Right? So in figure 1 and figure 2 when we observe, so in figure 2 the car is changed its position after 2 seconds. Right? So in figure 1 the place of the car is here. In figure 2, the position is changed from here to here. So after 2 seconds. But the place of the tree does not change here. So according to tree surroundings, the tree is at rest. So which one is moving here? The car is moving from one place to another place here. Right? So an object is said to be in motion if it changes its position with respect to its surroundings in a given time. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. So, an object is said to be at rest. So, when we'll say the object is at rest? So, an object is said to be at rest if there is no change in its position. If there is no change in its position with respect to its surroundings in a given time, then we can say that the object is at rest. So thus, we can say that the tree is at rest and the car is in motion while we observe them over a period of time, 2 seconds in this case. Yes, we observed 2 seconds in this case. So by observing this time, we say that the tree is at rest and the car is in motion. So can you give some more examples of objects which are at rest or in motion? So observe the picture carefully here. So observing motion of the car. So look at this figure 3 and figure 4. So look at the pictures. State which of the following statements are true here. So look at these statements. Now state these statements are true or not. So the distance between the driver and the car changes. So by observing these pictures, can you guess can you say the distance between the driver and the car changes or not? Here, the distance between the driver and the car does not change. Okay? Now, the distance between the car and gate of the house is changed. Is it true or not? Here, the distance between the car and gate of the house is changed. Right? So here, in figure 3, the position of the car is here. In figure 4, the position of the car is here. So here, and between the gate is here, right? So the distance between the car and gate of the house is changed. Now next one. So there is no change in the position of gate of the house with respect to its surroundings. Is it true or false? Here, there is no change in the position of the gate of the house with respect to its surroundings. Yes, this one is a true. So, there is no change in the position of the car with respect to its surroundings. Is it true? Here, there is no change in the position of the car with respect to its surroundings. Whether the car is in motion or is at rest. Yes, here there is a change in the position of the car with respect to its surroundings. Yes, with the given time interval, the position of the car is changed. So we can say that the position of the car is changed with respect to its surroundings. Yes. So from this, imagine that you sat in this moving car. Okay, so imagine that you sat in this moving car beside the driver. So would you observe any change in the driver's position? Is there any change in the scene you view through the window, buildings, trees, etc.? Here, as the car moves, the distance between you and the landmarks like buildings, trees, poles, etc. outside the car changes. Yes? So here, when the car is moving from one place to another place, the distance between you, right, and the landmarks like buildings, trees, poles, etc. outside the car changes. So this change in the scene you view through the window indicates that the car is moving. So, however, your position with respect to the driver of the car remains the same. Okay, there your position and the driver position remains same. There is no change in the position of you and the driver. Here, with respect to surroundings like buildings, trees, poles, etc., the car is moving, right? So that is you and the driver of the car at rest with respect to each other. Okay, with respect to you and driver, you both are at rest. But both of you are in motion with respect to the surroundings outside the car. Okay, those who are observing you people from outside, with respect to them, you are in motion. You and driver are in motion. But with respect to you and your driver, you both are at rest. But with respect to surroundings, you both are in motion. Okay? So, a body may be at rest with respect to one set of surroundings and at the same time be in motion with respect to another set of surroundings. So, thus motion is relative to the observer. Okay, with respect to one person, one object may be at rest. With respect to another person, the object maybe is in motion. So that is depends upon the observer. So we can say that motion is relative to the observer. Okay, so here when you are moving in a car, with respect to you and your driver, the trees, poles, buildings are moving backside. But with respect to the surrounding people, the trees, buildings, poles are at rest. Right? So here we can say that motion is relative to the observer. So I'll give you one more example to the relative, how the motion is relative. So for example, the two friends are moving. They reached one house. The person A and person B, assume that. So they reached one house. So when we ask one question to the person A, what is the position of the house? So the person A will say that this is left side to him, right? So the position of the house is left to person A. The same question if we are asking to person B, what he will say? He will say that the house is at right side. So who is correct here? So according to person A, the house is at left side, right? And according to person B, the house is at right side. So here both the answers are correct. So we can say that the location is relative. So the motion of an object is depends upon the observer. Right? So the person A is observing the house from his left side. Observer B is observing the house from his right side. So here both are correct. So we can say that location is relative. So simply we can say that the motion is relative to the observer.